Hi students, we'll be seeing now factor theorem. Now what is factor theorem? If a polynomial p of x is divisible by a linear factor x minus alpha, then p of alpha, which is the remainder, is 0. From remainder theorem we know that whenever p of x is divided by x minus alpha, the remainder is p of alpha, correct? But if it is divisible, that means x minus alpha completely divides p of x, then the remainder has to be 0. This is exactly what we say as factor theorem. That is, whenever p of alpha is 0, we can say x minus alpha is a factor of p of x. Now this is very useful when we have cubic equations in IIT problem and you guess one of the roots by checking this and then you claim that x minus alpha is a factor. Okay, so this is very useful as much as problem solving is concerned at competitive exams. So let us see an example of this. So the problem goes like this: given that x square plus x minus 6 is a factor of the polynomial 2x raised to 4 plus x cube minus ax square plus bx plus a plus b minus 1. Now if this is a factor of this polynomial, then we have to find a and b, which are the unknowns here. So what we do, we know that, again I'll just state the statement, that if p of alpha is 0, then x minus alpha is a factor of the polynomial p of x. Okay, now if you see here, since they have already stated that x square minus x square plus x minus 6 is a factor, let's see what is x square plus x minus 6. We can say x square plus x minus 6 as x plus 3 into x minus 2. Okay, so can I say this and this terms are factors of the polynomial p of x as stated above? Okay, if these are factors, then can I say p of minus 3 is 0 and p of plus 2 is also equal to 0, because you will equate them to 0 and you will find the alpha, right? Okay, so now when we have this particular structure that p of minus 3 is 0 and p of 2 is 0, what is p of x? I'll just write it down for you again. P of x above we took as x 2x raised to 4 minus, rather plus, x cube minus x square plus bx plus a plus b minus 1. So if p of minus 3 is 0, then what do we get? We substitute minus 3, so it will be 2 into minus 3 raised to 4 plus minus 3 the whole cube minus a times minus 3 square plus b into minus 3 plus a plus b minus 1, okay, is equal to 0. So you get an equation here, and that equation is going to be 134, which I've already calculated. Don't get surprised how come I got this equation. So it comes out to be, this equation comes out to be this equation. This is equation 1. And then again we have p of 2 is also 0. So we get, this is nothing but it comes out to be, I'll substitute that, it will be 2 raised to 4 plus 2 cube minus 4a plus 2b plus a plus b minus 1. This is also equal to 0. Okay, and if I simplify this, I get this as a minus b is equal to 13. Okay, if I simplify this particular equation, okay, I'll call this as 2. Now these are two equations in two unknowns. If we simplify them, which you can work out, a will be 16 and b will be equal to 3. Okay, so this is one use of factor theorem. Another use of factor theorem is sometimes a cubic equation is given to you and then you have to find out what are the factors. Especially in JEE problem, this becomes a very small part of the problem. Okay, I hope you have understood this particular problem. Let us get to the next problem. Okay, we'll try one more problem here, and this time we'll try to use remainder theorem as well. So now what we have is, the question is, let f of x be equal to x raised to 135 plus x raised to 125 minus x raised to 115 plus x raised to 5, this is 115, plus 1. Now if f of x is divided by x cube minus x, then the remainder is some function of x, say we say that as g of x, Now we have to find g of 10. Okay, so I'll just explain this problem, just go through it. Let f of x be given this polynomial. If f of x is divided by x cube minus x, then the remainder is some function of g of x. So let me write it in notational form. Dividend is equal to divisor into some quotient plus remainder, and they are saying let the remainder be g of x, some function of x. Okay, now as per our first note in the previous video, we know that this is the divisor and this is the remainder. Okay, so what did I say? Degree of remainder is always less than the degree of the divisor. Okay, so by that logic, if this is a cubic, the g of x is going to be a quadratic. So I'll just assume some quadratic, that is ax square plus bx plus c. This I am calling as g of x, I am taking as ax square plus bx plus c. Okay, I hope this is very clear till here. Now what I am doing is, I know the roots of this are the roots of x cube minus x. X cube minus x equals 0. If I substitute, I'll solve this. I'll get this is x minus 1, x into x minus 1 into x plus 1 is equal to 0. So the roots of this cubic is 0, 1 and minus 1. So what I do, now I put x equal to 0 here. I'll get f of 0 is equal to, this will become 0. Okay, because 0 minus 0. So this entire term vanishes and I'll get a times 0 square plus b times 0 plus c, which comes out to be c. Okay, simplifying this, what is f of 0? Go back to the original equation. F of 0 may, all these terms will vanish, the first 4 terms, because you are substituting 0. So you'll get here only 1 and this will become c is equal to 1. So you got one information from the first simplification. Okay, now what we do is, let us put x is equal to 1 because that's the next root here. So if I put x equal to 1, I'll get f of 1 is equal to a times 1 square plus b times 1 plus c. Okay, and this comes out to be a plus b plus c. But what is f of 1? Go back to this polynomial above and substitute 1 there. So f of 1 will be equal to 1 plus 1 minus 1 plus 1 plus 1. So that comes out to be 2, 1, 2 and 3. Okay, I hope that is correct because there is only one subtraction which takes place. So 3 is equal to a plus b plus c, which is nothing but a plus b plus 1. So I get the condition a plus b is equal to 2. Okay, now let us go ahead. I'll just shrink this entire discussion so that we'll get more room on the screen. Okay, now if you see here, now we start working on the other condition, that is we have substituted what all things, x equal to 0, x equal to 1. Now we substitute x is equal to x equal to minus 1 because that's the only root which is left on the right, you can see. Okay, so I substitute x equal to minus 1. So when I substitute x equal to minus 1, I'll get f of minus 1 is equal to a into minus 1 square plus b into minus 1 plus c is equal to a minus b plus c. Okay, and this will be equal to, if I substitute f of this minus 1 in the function, I'll substitute it here. So I'll get minus 1 minus 1, okay, plus 1, so it will be minus 1 minus 2 minus 1. So it will come out to be a minus b plus c is minus 1. Let us calculate that again. It will be minus 1 plus 1 because all powers are odd. Okay, if you see, this cancels and you get minus 1. Okay, I hope that is very clear. Now let us see. Now we have got this condition. Now we'll substitute c as 1 from the already defined condition. So c is 1 means a minus b is equal to minus 2. Now I simplify these two conditions here, this condition and this condition, because we are supposed to find a and b. So a plus b is 2 and a minus b is minus 2. I simplify, add these two equations. I'll get 2a is equal to 0. So a is equal to 0. And from this, any of the equations, I get b is equal to 2. So typically what we have got, a is 0. So ax square plus bx plus c is my g of x function, which is 0x square plus 2x plus 1. So essentially, the g of x function is 2x plus 1, and they have asked us to calculate g of 10, which comes out to be 2 into 10 plus 1, which comes out to be 21. I hope this use of remainder and factor theorem both is very evident. I hope this is very clear. Just have a look at it. Okay, so I'll just shrink it so that you can see the entire solution. Okay, thank you very much.